So I leave the cloud to go to the Zscaler proxy, get the traffic inspected, return to the cloud. Now, mind you, I paid egress as soon as I left the cloud. And it's either 9 cents a gig an hour over internet or about 4 cents over a layer 2 circuit, like a direct connect interconnect from Google or Express from Azure, and go back to the user.
I have a ton I want to ask you. I've been thinking about how to start this, which is before we get into the customer stories, I want to go a little bit out of order, which is like inception founding idea, right? Because founders came from other SD-WAN platforms. And let's start there.
Okay. So I work for a company called Alkira, as you're well aware, and Alkira was founded by two gentlemen, they're brothers, Amr and Atif Khan, and I've worked for them before at Viptela. And it's probably good to go back to 2012 at the birth of, and even further. So Martin Casado comes up with all of these patents, and ultimately those patents evolve, or the ideas behind those patents evolve to, as you're probably well aware, software-defined everything, right? So Martin's at VMware at the time, I think, when he's getting these patents. And then he goes to become an investor, like a lot of guys who make a lot of money in the Valley. They go and find small companies. And I happen to land at CloudGenix, right? I was the second sales guy hired at CloudGenix. And I get an opportunity to meet Hans Robertson, who's one of the founders of Meraki, and Martin Casado, and we're all hanging out in the bar, and it's me and the CEO and a couple other folks right there. So I'm kind of picking Martin's brain because you don't really have an opportunity to do this very often, right? And this is, if you're a networking nerd, he's one of our heroes, right? So he's telling me this, that, and the other. And CloudGenix had kind of a really interesting architecture. It was Kamar and Manny and Mukhtiar and all those guys who founded CloudGenix. They came from Cisco WAS, the wide area acceleration, whatever it was, solution. And it was an inline solution, right? So you've got data center. There's no separation of control plane and data plane, which is kind of an issue when it gets to scale. Funny story, we had about a whole bunch of gear inside of, let's just say, a big American bank. And there were a bunch of bad DIMMs. You probably remember this, dual inline memory modules that came out, and this would have been 2014, 15, 16, right? So around that time. And everybody suffered the same problem, right? The DIMMs caught fire. The data center caught fire. The customer's like, hey, my data center's on fire, and your box is the cause. And so, to CloudGenix's credit, we got that box replaced. When I joined Viptela, 2015 area, and started working for Amr and Atif, they had a different architectural approach. And it's relevant to both Viptela and Alkira. At Viptela, we were virtualizing the underlay, right? Which is what Martin really came up with. But we're also decoupling control plane from data plane, which gives us the scale. So nothing's in line, effectively, right? I've got a bunch of nodes basically connected to a bunch of BFD tunnels that are getting instructions from control element or an orchestrator that's been decoupled from the data plane. So the forwarding plane stays up. And the reason this is important is when AWS East 1 goes down.
Never happens.
It happens so often. When the cloud region goes down, if you have an inline solution, like CloudGenix and now Palo Prisma, and this is not, I'm not, talking trash, I'm just stating the architectural facts. You're a bit limited on what you can do on the forwarding plane, right? If you lose your data center node that's driving the traffic. When you decouple control from data plane, the tunnels, the BFD tunnels at Viptela, we would just advise people, well, don't make any control or orchestration changes. Don't make a policy change in the orchestrator that would influence the data plane, because effectively, they're separate and you've got this outage. So with the most And that philosophy is kind of one of the driving forces behind Alkira. But we'll get to the founding story in a second. Why it's relevant in outages is you can route around things like AWS East if you have a forwarding plane that is not dependent on the control element. Same with the CrowdStrike. I'm driving across the country. So the wife and I move out from Washington, D.C. to California. We've got some family stuff we need to take care of. So we're on the drive and CrowdStrike pushes the bad code, right? And it's like 4:00 in the morning and I'm stopping to get gas and I get my credit card out and I hit the POS and nothing.
Yeah.
And I'm like, well, I typically pay my bills. So I try all the credit cards and none of them work. And I'm like, this POS machine is down. I go in and the guy goes, yeah, none of that's working. It's cash only. And I'm like, well, is the ATM working? No, the ATM's not working either. I'm like, well,
that's a problem.
So yes, I call into support at Alkira, right? Because it's during my tenure at Alkira. And I was, I'm like, are we up? And sure enough, we are. And it's largely because we're able to, the forwarding plane exists as its own separate element effectively, along with the orchestrator and the management plane as well.
Early SD-WAN, early SD-WAN was, let's get rid of MPLS.
Indeed.
Right. That was a big part of it. And then we get all these different SD-WAN implementations. People have different, you talk about CloudGenix now,
right.
Palos, and there's a lot of different approaches to it.
Mm-hmm.
How much of Alkira was, we're going to solve a problem or we're inventing a new solution, right? Like we're on that scale, like, oh, we did it this way. It wasn't the right way. We're going to do it a different way. Or was it just like, there's just a different problem out there we need to solve?
Amar and Atef are trying to solve a different problem. We are solving a different problem. And that is between all the different cloud service providers, from AWS to Oracle to Tencent to Ali to IBM to Azure, GCP, all of it. They all speak a different native networking language.
Mm-hmm.
They have different native networking constructs, right? Mm-hmm. And so they set out to remove the complexity of multi-cloud networking, but and maybe more interestingly, they took a look at the Equinix model and the Megaport, all of the on-premise data centers, which are really and have been the gateway to cloud, right? It's a cross connect inside of each of those. It's 18 inches. You're moving from one port to another port to get up into this ephemeral abstraction we call the cloud. They go, well, why don't we just build a virtualized co-location facility inside of each of the cloud service provider AZs, the availability zones? And these are routing guys, right? Which is really the sort of the kernel or the birth of the idea. If you start with routing, you never really go wrong. And you'll get arguments from Jay at Zscaler, right? He'll say, yeah, you don't need any routing. Okay. But again, let's go back to the AWS outage. Let's go back to the CrowdStrike outage. And let's go back to any sort of routing where there's, like, it was maybe 3 or 4 weeks ago, we're on with a customer in AWS. AWS, by the way, has had, I know that you're aware, they've had a fairly significant brain drain. And there were a ton of smart people at AWS, and there still are. Don't get me wrong. But there are not a whole lot of routing guys left.
Yeah.
Right?
Yeah.
So we do a lot of support for AWS, and we do it ostensibly through our customer who's having a problem. And, at first it's always, and you're in the business, so you get this. It's always, everybody points fingers. It's always the network.
Yeah, that's the first one for sure.
No, it's always DNS, but that's not exactly an inside joke, right? Everybody should know that joke.
I mean, at this point, everybody should get it.
Right. So we end up supporting AWS to solve various customer issues, and it's always some sort of routing issue inside of the AWS stack. And you're just like, hey, what happened to all your good, sort of routing nerds, right? Well, they retired, they got riffed, they got laid off, they're working at they're working at GCP now. or something like that. So Amarnath set out to virtualize a co-location facility in each of the cloud regions and to normalize the communications between the different cloud service providers. They do it with a routed overlay that sits on top and uses and iterates on the cloud infrastructure. So not only do we use what we effectively do is attract customer traffic to a big VPC that contains our stack, right? Or a VNet or a VCN, whatever. And that's cool. But what the really neat thing is if you overlay all of public cloud and you normalize those communications, you don't have any barriers to enter the cloud. And it's not a financial barrier in the traditional sense, a barriers to enter or market or what have you. It's a technical. It's hey, I need to go get AWS certified, GCP certified, Azure certified, OCI certified, and that takes time and effort and money. If I wonder, and I'm sure you do too, remember the guys with a CCIE number less than 5,000 were making big dough, right? Because they were the cream of the crop and they went through their program. They had all those technical certifications. There aren't a lot of those guys left.
In the last 15 years, networking has gone to basically zero.
Right.
Like it's I have lots of conversations with new companies, new clients, and you get this perception of like, oh, it just works in my house. Like I just, that's what I want in the office. Like I just want to be wireless everywhere. We don't need to have wires. We don't need to have a network. We can just be wireless. And you're like, you want to put 600 devices in this footprint, it doesn't work this way, and you can't, but there's a lot of things where it's like, you can't, people have to experience it before they understand it to a certain degree. You can't get into a conversation with a CTO who's never had any experience with running physical infrastructure and explain to them like, this is not how physical infrastructure works, or what the trade-offs or the negatives of this plan that you have is. You can counsel, but sometimes you just have to let them experience it, and then they experience it and say, okay, we're going to do something different. And the cloud's been really interesting in this one because, this idea of like, you say like there's this drain of router nerds, right? Like I'm a router nerd. Nobody has any idea what's going on anymore. You mentioned earlier.
Well said.
You mentioned earlier with you said two things I wrote down here. It's always a network. I had a framed plaque in my office years ago, and it said, "Don't blame me, it's a network problem." And of course, I was a network engineer, right? So that was the inside joke. CloudGenix, a friend at CloudGenix coined the term, time to innocence. And CloudGenix architecture, in terms of what they were doing on the edge was really interesting, and tracking and making path decisions based on actual layer 7 performance was awesome. But then you start unpacking the rest of the architecture and you're like, we have to pen all of this in a hub and spoke back into a data center, and or multiple data centers. You're like, what problem are we solving here? It's like you're solving a problem for the edge connecting to centralized resources if you're a large bank and that's what you have because you still have physical data centers. And then Palo buys CloudGenix and then overlays Prisma on top of it. And then when you start whiteboarding out that solution, I don't know why you would implement it is basically where I get to.
Is no comment an option on this?
No.
I think you are exactly right. Right. So when we started the conversation about MPLS, what deprecating your MPLS bill was sort of the goal, right? If I can remove some of that cost and come up with a way to virtualize the underlay and move traffic between links, I can take advantage of internet. And internet along the way, CloudGenix was founded just like every SD-WAN vendor, the four, in 2012, when MPLS was still $3,500, $4,000 a month in most markets, right? And that's when you've got the 600 sites, it becomes cost prohibitive, or at least it's a big nut that you have to contend with, limits your ability to scale up from a personnel perspective and to do interesting and elastic things. And then you've got this and we'll get back to the CloudGenix architecture in a second, but you've got this sort of new domain space, right? And the new domain space is just sort of an ephemeral data center, right? You're abstracting a data center out of a data center, and you're providing tools to build applications, and you're doing all of this cool stuff, right? You've got storage, you've got databases out there, you've got different application vehicles that help people build the front end of application. And then you start really taking advantage of what the elasticity of the cloud and what it has to offer, and the speed to market. Not only does the time to innocent change, right? But if you look at traditional architectures, that time to innocence almost increases, right? Dramatically, because you now remember when SD-WAN first came out. We got rid of MPLS. We moved to an internet and MPLS. So you still had a little bit of it left. And then you had more stability in internet. You had more pipe for less money. And people go, well, why can't I use 2 internet circuits out of my SD-WAN appliance? I can do all this cool stuff. I can move voice traffic over from link to link. I can, at a layer 7 perspective, take a look at loss, latency, and jitter, and different application metrics like round trip stuff. That was really cool, right? But when you now have a new domain space at the top of the stack, and largely applications, a giant subset of applications have moved to this new domain space, then you've got a new and evolving issue, which is, hey, I've got workloads in data centers that I don't have the talent to manage, right? And I see that as sort of the first problem, right? This complexity, and that's what Amr and Ataf set out to solve. Time to innocence, as I recall, was coined by a fellow called Vijay Sagar. Is Vijay a friend of yours?
So I got it from another person at CloudGenix.
Oh, okay, right on. Fair enough. Vijay's a great guy, by the way. But that was a really good experience. You know?
This has gotten really... The frustrating thing about technology for me is you get into the situation where you're trying to simplify and make people's lives easier. I mean, that's like we talk about, we're trying to make people's lives better, right? That's like our underlying mission statement. And technology improves the human condition, right? Like it's this thing that like it makes the world better. But then we get into a situation where it's like, are we creating more complication than we're simplifying along the way, right? So we have this SD-WAN thing come out, right? And then everybody wants to run in and say we're SD-WAN. And you have the original SD-WANs in 2012 that were solving, MPLS. Like, how do we get rid of this $3,500 circuit and move it to something so we can have only one or none and use the internet? And then you find out like, oh, there's all these like hairy things about the enterprise we didn't think about. You have NAT boundary traversal issues with like voice traffic and real-time media and like all these other things you have to solve. And so then you have to now account for a gateway. You have to have that gateway routing traffic back. And then you have all these things and your Visio just gets worse and worse and worse. And then what's the next stack in this one? And then of course every vendor's like, oh, we're cloud managed, we're SD-WAN, right? So now we've got these boxes, all these boxes that claim that they're SD-WAN, and you're like, you're not like, what are you actually doing? I'm not going to name names, but I can get on that rant.
Talk later.
Yeah. So we go down that path, and then it gets even more complicated because then we get SSE and SASE, right? And like, and the people that coined the terms SSE and SASE, can't even really define what SSE and SASE is anymore.
Right.
And then of course in the modern enterprise, depending on where you are in that life cycle, do you have a premise? Do you not have a premise? Do you have a data center? Do you not have a data center? Do you have cloud infrastructure that you're managing? Are you single region? Are you multi-region? Where are your SaaS applications actually housed out of? And you start to unpack this. And I don't think a lot of people really spend a lot of time thinking about where their applications and their data actually resides and what problem are they trying to solve anymore.
I think that they're starting to. So GCP had a really, I think you and I are the same mind that the objective for a business should always be to provide a simplified operational way to make a problem disappear, right? To solve, we always focus on solving a customer problem. But sometimes it takes a while for the customer problem to present itself or to evolve. And I'll give you a great example. So GCP, they have a big Australian pension fund. The pension fund, one day, it's an Australian pensioners fund. It's $54 billion worth of dough, and it's basically, for all intents and purposes, being stored in GCP box. And then there's an issue, probably a DNS issue. But they lose a bunch of the Google VPCs that contain the $54 billion worth of pensioner dough. They had to go back to the tape, believe it or not, the tapes.
But they had it.
No kidding, right?
Yeah.
Otherwise, you've got no idea how to. The money itself is not going to disappear. Just the record of who owns the money and how much it was is really what we're talking about. Those are fairly large stakes. I'm not sure that was the first instance where enterprise customers decided we need to be multi-cloud, but it certainly was a pretty good reason to sort of not keep all of your eggs in a singular basket, right? So, okay, you solve a problem at the same time you're now creating another problem, which is, hey, GCP is great. They're great tools. Google is an ongoing concern. I don't think they're going to go anywhere. Yeah, we had a little blip. We lost $54 billion, but who's counting, really? So you move some of your assets into AWS, and maybe you're aggressive and you go Azure and Oracle as well. Your guys are GCP guys. They don't know jack about those other properties or those other data centers with those different tool sets and native networking constructs. How do you remediate that lack of knowledge, of FTE knowledge? How do you get through that new problem gate easily? And that's the whole purpose of Alkira, is to decomplexify the different cloud service provider native networking constructs and to make it so that a username and password and a little etch-a-sketching your network together. You said Visio earlier, which kind of made me laugh.
Yeah, going way back there.
We just do it in real time now, where we're architecting. We automate the attachment of all the cloud workloads. We automate the attachment of the WAN workloads. And then we allow you to instantiate services in the middle as virtualized network functions, right? So find the fastest path to your SaaS app, and you take a Palo Fortinet checkpoint or Cisco firewall. As a VNF, you put it in the middle of our stack. And let's say, we're full mesh active, right? So, and we always deploy in HA pairs. So customer brings the packet to my virtual port, our virtual port. The Palo is sitting right there, and it's talking back to the Panorama because I'm going to get the IP address. The customer is going to enter the IP address of the Panorama server. So they're reusing the same policy that they've always had, right? And that CXP operates in AWS the same way it does in Azure, and our CXP is the Cloud Exchange Point. That's our virtualized colocation or our network infrastructure that we are giving to our customers to use and build their networks. Now you've got a CXP and GCP, Azure, and AWS, and they all operate the same way. It's the same workflow. They speak the same language. And so if you're the pensioners who've lost $54 billion and the folks that need to support that fund, you can move those zeros and ones from one cloud to another with no issues, because it's going to operate the same way. It's username, password, and then you construct a really simple network. That's very complex, of course.
The thing that's like rattling in the back of my head as we're talking about this is, from an architecture standpoint, what's actually deployed. Let's just focus on the edge for a second.
Sure.
You still need something on the edge.
Absolutely.
There's still something providing, what we call now SD-WAN for most people really just means like path selection of our internet circuits, right?
Sure.
Because you are taking and building IPsec tunnels to the edge is taking and building an IPsec tunnel to you, and then you're providing routing. So what's interesting about this architecture for me is you're I don't want to say virtualizing routing function, but you're providing this orchestration and control for routing for a diverse set of workloads and applications.
Yeah. So let's start with the edge. If I had a really interesting conversation with a partner. As you know, I take care of all of our partners. And he comes to me and he says, I have this gaming company and they have 500 sites and they need to update the ISRs, the Cisco ISR routers in these sites. And my first thought was, why? Oh, well, they're at this end of sale. And like, I've worked at Cisco. When they're end of sale, you got another 18 months, 2 years probably.
Go gray market.
And you can go gray market. And then, you know, you've got a lot of people out there that can support Cisco appliances. And so I say to him, okay, well, what are you going to replace the ISRs with? And he goes, the customer's thinking about putting the PANs in there. And I'm like, okay, wait a minute. So you're going to put firewall in there, right? And you're going to put tunnels in and out of the firewall. Yeah. I'm like, okay, how many sites? And right now I know you're shaking your head, and I was.
There's so much.
There's so much wrong with that deployment, but whatever. Because it gets worse. I'm like, okay, where are these? Where are these? The ISRs that you're going to replace? Well, here's the funny thing. They're all in casinos. I'm like, well, what's your change window and time frame look like? And he goes, well, that's kind of the rub. I'm like, yeah, because these places are open up on Christmas and 24/7 all the time. You're going to take their device down and replace it. So what's that going to cost you? And he's like, 12 million. I'm like, okay, wait. The palos and the trucks, plus the labor, and getting into the casinos, which is going to take you years. All right, I have a better idea. Don't buy the palos. Sweat the asset, maybe kick the can down the road a little bit. But as long as it can build a tunnel, you can then tunnel out to the virtual port on our exchange point in the cloud. So there's, you know, it's like gone are the days of thinking about an on-ramp. Ours is just here. I'll give you a little bit of Python script and you paste it into a CLI, and then you find the virtual port and you join a global network with a high throughput, low latency backbone that rides across all clouds, gets you into China and out of China, all of that stuff, right? What about that idea? Well, the customer really likes Palo. I'm like, okay, man, you can lead a horse to water. But I have the same issue as you do.
I got introduced to a company, and they were a complete Cisco shop, and they'd hired a new CTO. And the CTO, you know, the first time I spoke with him, it was, what was this phrase? It was something like, you know, Cisco isn't great, so we're going to replace everything with Juniper. And my first question was, what do your employees know? You know, because Cisco CLI and Juniper, you know, at that point it was iOS. They weren't on iOS XR, which I get it. If you were on iOS, you wanted to be off iOS, right? But it was like, oh yeah, we're just going to teach. Everybody's just going to learn JunoS and become Juniper people. I'm like, this is not happening for you. Like, I'm sorry, you know. Needless to say, they spent a lot of money and they didn't finish the project. Like, it was just, it's the change management. I had this explained to me by a similar story. Going through it, and you're like, okay, we want to roll out a software patch. You're like, you have 1,000 endpoints, you know, firewalls deployed or routers deployed on your field, you know, which is not a lot of equipment. 500 sites, 2 devices, it's 1,000 devices, right? You're like, we have to go through a change management process before we can certify and apply a patch. And you're like, you can only do so many in your window, in your windows once a week. You're like, okay, if you can do 10 devices a week, you've got 50 weeks, you know, 50 locations a week. You have 50 weeks to roll this thing out. So you're like, great. So by the time you patch your entire fleet, you're like, you never catch up. You know, it's just, it never ends. Right. And but it also, it's like the role of your edge and what you're trying to accomplish changes a lot. I had an executive tell me, he was trying to build networks, and his phrase was, "I just want these things to be fancy Starbucks. I don't want any sophistication on the edge. Like, I want nothing there. I want people to have internet access." And it worked for them because they were AWS native and they were all SaaS native, and they didn't have any prim emphasis. I mean, this is years ago. This is a long time ago. So he was new to the party in this mentality, but they were already there from an infrastructure standpoint in the business, and they could justify it because they didn't need this stuff, right? They didn't have a phone system, like it was one of these things. But now I see a lot of companies, mid-market companies, 1,000, 2,000 employees, they've got one network engineer, like, to support your entire operations, and it's a really interesting thing. And of course, some of the big brand name firewall vendors do a really good job of convincing executives that they're the only game in town, and if you're not running them, there's something wrong with your infrastructure, and they cast the suspicion really well.
Yeah, there's a whole lot to unpack there, right? But I think the majority of legacy vendors are interested in protecting share, and that they don't always, while the intention when they started and were founded was admirable and well-intended, I think maintaining that share has its own sort of, bankrupt. It just, because look,
this isn't the thought.
People engineer complexity into their networks to satisfy a vendor relationship they have. They don't always find the easiest way of doing things. They don't always say, why do I have 500 Fortinet boxes at the edge? I'm 5 milliseconds away from the cloud. If I put a couple of 40s up in the cloud, tie it back to FortiManager, doesn't that accomplish the same thing? I mean,
by the way, if you listen to earnings calls from any of these companies, this isn't like I think. I mean, they will talk about what their replacement rates based on generations of when equipment sold, right? So,
right.
Part of financial management for any of these companies is, if a box is sold in 2020, how long does that stay on service, and what's the replacement cycle for that box they're predicting revenue down the road for? And then where are they in that, in terms of that, what percentage of that fleet has been replaced, and is it tracking, is it not tracking? And now all these companies have to move into this like SASE idea, but that's a really complicated thing for them because it changes architecture, and you have to do it in a very specific way, because if you push people too hard into this idea of SASE and cloud security, now you're opening up competition to come in. And do we have to evaluate architecture? Do we want to stay with you, or do we want to go somewhere else? And that's complicated as well. And then of course you have the real complicated things, which is, what do your employees and your support partners know and understand? And what can you maintain long term? And what can you get parts for long term? And change management from like a rip and replace from a logo on a box is really complicated. It's easy if you don't have any infrastructure. If you're 10 sites and you've got nothing, like, who cares?
Right.
But you get into like these bigger things, and it becomes a big problem. How much of this, I know a lot of, we work with I can't say how specific I can give this. I'll say I know a lot of companies that are single region AWS environments, and a lot of them have played with this idea of multi-cloud, and it usually was a workload, right? Like, let's put TensorFlow looks really fun. Let's put BigQuery and TensorFlow workloads into Google.
Yep.
And the economic decisions that then force other architectures come into play. Like, do we have an EDP? Are we under our spend threshold on EDP? Do we need to move stuff back over here because we need to, that becomes a real concern for companies. And there's, this migration of data back and forth. You talk about complexity, and these clouds talk different languages. Mm-hmm. I was introduced to a company, 8-figure spend on the cloud, right? And they were having a problem establishing a VPN between infrastructure. They were looking at bare metal, and they couldn't get the VPN up. And I was talking with their team, and I was like, okay, I'll help you troubleshoot this VPN issue. And what have you done? Oh, we clicked the button for VPN in the console, and it didn't work. And I'm like, I don't, and but I, okay. Of course it didn't work. You didn't configure anything. You know, like, but VPN. But that's the thing, right? Like we talked about SD-WAN. I supported Cisco for a long time as a network engineer, right? Like every time I got a Cisco VPN up and running, I couldn't tell you why it was working. You know, I was a fairly competent network engineer, and like it would work. It'd be like, okay, don't breathe on it too hard, right? Like,
Yeah. Again, there's a lot to unpack in there. Um, I was thinking earlier that when have you heard a Palo guy come into a shop and say, you know what, we're lowering the price on the refresh gear?
oh no, come on, that's not going to happen.
Right.
You have to buy a bigger box with more capability.
Well, absolutely. There's it's faster, feeds and speeds. It's got all these new whiz-bang features.
Deep packet inspection.
Right. Although I have run into a pretty cool couple of companies doing some interesting work in DPI recently. But anyways, that's a different.
You know, my question is, whenever I hear
Yeah.
that come up, I ask the actual IT team,
Mm-hmm.
show me your Outlook folder where you filter all of your alerts into. I want to see what that looks like. And that's the answer. All the DPI, if you turn it on, it's like one of two things happen. Either you turn it on, you kill your box, so you turn it off, or you turn it on, you get a lot of alerts, you filter the alerts out because you don't have time to even look at them.
Right.
You know?
Yeah. I think our bias, for me, it's easy. I go and I talk to our partners about disrupting traditional architecture. So we go back to the edge and go back to the SASE, SSE stuff. I think that's sort of a step along the way to probably what's architectures are always evolving, right? My thing is all the architectures you should adopt or that you adopt should be extensible. You should be able to extend your architecture without a whole lot of effort to a different place, to a different workload, to a different person. The person on the ground, and I've heard the Starbucks thing before as well. I like that model of just having an access point, whatever it is, and then doing, some identity and context before you allow the person to access the corporate network. I think that's a good idea. We sit in Starbucks, you hop on your VPN, you go through your credentialing, you've got a couple of, your dual authentication, and then you're on that. And then you've got access to a subset of applications that allow you to do your job, right? It shouldn't be any more complicated than that, but there are
So complicated,
a
though.
gazillion point solutions to address just that from edge to corporate network, no matter where the
I mean,
right?
your description, I'm thinking about it in my head. There's like 11 acronyms at play, right?
Right. Right. I mean, so, one of the things that we've been thinking a lot, we just turned up an MCP server. And I made a kind of because I'm old school, we're probably about the same age, right? I made a Tron joke. Remember the master control program?
Of course, that's where it comes from. I mean, let's be real.
Exactly. This is what I thought.
There are no accidents in tech naming.
No, there are no accidents. So, okay, so now you have entirely disaggregated applications checking different data sources, running across the entirety of your network, right? How do you secure that? Unless you have an extensible network that you can extend to all workloads, all data sets, all infrastructure, all people, and that it's not a barrier to the outcome you're seeking. And because you and I, we serve the business so that they can go on and do what they want. And we forget a lot about that. IT becomes sort of, as you know, a business blocker sometimes because there's too much complexity. Like my wife, I have some leadership at a big, giant, multi-billion-dollar commercial construction firm. We'll just put it like that. And every time she has an issue, I'm like, I end up troubleshooting it for starters, which was not part of the arrangement when I got married, but it is what it is. And she's got all the layer 8 issues that you can imagine.
Yeah.
So I sit down in her crap ass Dell box and, pardon me, I should edit that out. Okay. My bias Dell to myself. And I solve her problem, right? And it's invariably, it's something simple that she's overlooked or something like that. And I get her back into her construction management program that allows her to plan the job or do her MSR or to do this, that, or the other. But I always think to myself, these guys are the IT shop at her place of business. They've got an impossible job. They've got an absolutely impossible job. And I have a lot of sympathy for them, sort of paired up with the criticism that I have of them as well, which is not the kindest thing in the world, but whatever. I'll move past my own shortcomings. So they've got job sites thousands of job sites that you turn up, that you have to secure, with a whole bunch of people hanging off of that job site, right? With a whole bunch of different appliances with different code, different OSs, different everything on them. Further, they're going to go and access a whole bunch of data center applications and a whole bunch of cloud workloads and stuff. And, it's a company that started in the Bay Area and was, 3 guys that started it, and then they had a really good culture. They still have a really good culture, but it grew like wildfire. And I'll go back to the extensibility. Unless you have an architecture that's extensible, you can't address new domain spaces like cloud. You can't address, the deprecation of a data center or trying to turn something down or a switch from MPLS to Direct Connect, Express Route, Interconnect, or SD-WAN or IPsec, right? I think their job is very difficult because there are no constants. It's all variables all the time.
Well,
I know you know.
The friction with IT for a lot of organizations is that IT is not making the decisions, right? So a business unit makes a decision, fill in the blank, right?
Mm-hmm.
But then IT has to run and own that decision, which then creates a lot of problems because, you get into the cycle where, shadow IT, right? Shadow IT comes about because people just want to go get stuff to run their work, and IT doesn't like that because now they're responsible for it, but they didn't choose it, which is a normal cycle anyways. So then, but if you're in an environment where you get yelled at when stuff goes offline because the business can't function, but you didn't pick what the choice was. And so now you have to try to engineer to keep the thing online when you didn't choose it in the first place, but now you own it, right? Like it's designed to fail from the beginning, really, and and it becomes really complicated. Most companies, this, like most companies, IT teams are not reporting into technical leadership, right? They're an administrative function that's attached to finance. And how does finance manage things? Okay, what's your cost expenditure on this? We get these horrible terms I'll rant about forever. ROI and TCO. It's like, what are we comparing this to? We're comparing this to what we had beforehand, right? So now you're in an acquisition cycle where we're trying to replace something because we can't explain the business requirement properly to actually justify this against revenue or expense or whatever it is. So we can justify it against what we're currently spending. We're currently spending this much money on MPLS. We can replace it with this other thing, which is going to cost us less money. Success. Let's go do it, right? And then you find out, was that actually a good idea or was it a bad idea? But now you're on a life cycle of 5-7 years on this stuff now that you have to, because you're not going to get budget to replace what you just did for a long way down the road. And that leads to other problems, which is like over provisioning. I see more IT projects die because the IT team is trying to bank in over provisioning because they know they'll never be able to get budget for this thing in the future. And then the company sees it and they're like, no, we're not going to spend that money on this thing, and it's crazy.
Think of capacity planning. I'll tell you a funny anecdote.
How do you capacity plan when you're not involved in the process in the first place, right?
Exactly. So early in my tenure, I used at Alkira, we talked to a lot of partners, but we also talked to a lot of customers, right? Attached to those partners. And I'd always ask this one question. Right? I'm like, how many VPCs, if they're an AWS shop, how many VPCs do you have?
Do they know?
The thing is, they always come back with a number that was fairly specific. Oh, we've got 12 to 15 VPCs. And then you go into the console and they have like 50 that they're unaware of. Because, the great thing about a new domain space and the bad thing about a new domain space like cloud, it's sort of evolution into our lives technically, is that it does become sort of the playing field of all the shadow IT that goes on. So, I mean, think about all the developers that have their own VPCs and they're just testing a function inside of an application, right? And then that VPC has firewall. It's internet facing sometimes, and you're like, wow.
This show exists because of what we do at itbroker.com. If you're in the middle of a real tech decision right now, new technology, vendor selection, a contract that doesn't feel right, an M&A event that just landed on your lap, and so on, we help buyers like you get it right. Independent strategy, sourcing, and contract negotiation. No kickbacks, no sales quotas, just someone in your corner. Schedule a call at itbroker.com. Back to the episode. So as from the Alkira perspective,
Yes, sir.
how much of this is fixing routing and how much of this is like future proofing around this merger between the network and the security stack?
So, I mean, I think you know where I fall. I think the routing, the lost art of routing, which we automate, it's a BGP overlay, right? Will always be seminal, right? We are who we are, right? We're networking people. We want to get a packet from here to there, and we want to find the best path, right? The best and most uninterrupted path. What we discovered is that there are problems within problems. They're always, right? And I was talking about this earlier. You with the pension fund, you solve one problem and you create another problem. Anytime you create another problem, there are interdependencies that become problematic as well, right? And if I'm a person sitting at Starbucks and I need to access my corporate network, again, you said it, there are 12 sort of things I need to contemplate just to attach that person to my corporate network, right? So it's always going to be about routing for us, but that's the foundation on which we grew the solution. Now we're moving into sort of more nuanced territory. And what I mean by that is like, okay, I kind of see the world as flat. I mean, I know that the earth is round, but I don't participate in that camp of craziness. But I see with a forwarding or data plane that can go everywhere and can accommodate connections from every corner of the world and every device on the planet is the ultimate objective, right? The network, should be kind of flat and should be really easy to operate. So we start with routing and then we start addressing larger problems. And remind me of the second part of your question, because I started thinking about all the routing anecdotes and then.
No, I mean, it's just like, what is the future state problem here that we're building to?
Okay. So let's go back to capacity planning. You had argued that IT really no longer rolls up through technical leadership, that they're sort of chained to the...
Depends on the company.
Yeah, it depends on the company.
Yep.
So, okay. The IT folks are trying to do capacity planning and they're making the requests to get budget for that, right? And they get shot down and they can't do any capacity planning. Well, if you have the elasticity of cloud, and you can, we're sort of transitioning, I think, and I'm getting your future state question, but we're sort of transitioning to a consumption-based model. And I like this because it allows me to, if I'm a retailer at Christmas, to increase my firewall coverage area and or to increase the resources available for the point of sale machines so that I can make more sales and create more credit card transactions. And, and if it's usage based or sort of an OpEx thing, then you can scale down after your busy season. And I see compute and storage in that way. The network had never really been that, right? We have in China, let's talk China for a second. So we have a half dozen customers with facilities in China that they wanted to add to their corporate network. But if they did that in traditional networking sense, they'd need to go get the 3Cs, right? They'd need to get the Chinese certifications with not only, that the government insists on. But AWS and Azure are there, right? And AWS and Azure have done business in mainland China for a while now, not just Hong Kong, So with the geopolitical stuff that's going on and with the tariffs, despite the, what I read in the various papers about, Xi Jinping and our president making a deal to remediate the impact of the tariffs. Okay, there's still geopolitical winds that will influence some companies' ability to operate in mainland China. And so if they go in a usage base and they just consume what they need when they need it, right? And if it's competitively priced, I can get my sites in China connected to AWS and then distribute that packet, that data traffic, across to the corporate network from rest of world with a username and a password today in minutes. And all I need on the other side, on WAN side, is an IPsec tunnel from the Chinese office to the virtual port on our exchange point in China.
Two phrases I hate are consolidation and convergence. And consolidation, I think, is a good thing, but it's applied incorrectly in a lot of places.
Agreed.
But part of this whole thing becomes like, hey, analyst releases some new acronym, so everybody tries to rush into that acronym, right? And people that maybe were good SD-WAN vendors or were solving a specific problem in the SD-WAN space or the networking space then have to become also security vendors or go partner with some security vendor that has, so they can say we're a full SASE shop.
Right.
And then you look at the SASE shops and you're like, from an engineer, right, from a network architecture standpoint, I think about these things and you're like, okay, we have functions that we have to deliver, right? Do we deliver this and do we solve this problem by putting in a SASE solution and use a CASB to access our SaaS application and have authentication and audit? And then what do we do on our edge? Do we have an edge? Do we not have an edge? Do we just have some sort of STP software running, fancy VPN software running on the client, right? But like, where do we stick all this stuff, right? Do the firewalls have to exist? Do they stay on the edge? Do we reuse existing firewalls? Do we, what's doing the routing function? Okay, great. So, it feels like, we've got this like ever evolving, shifting Lego block, kind of thing that's like, does it sit here? Does it sit here? Does it sit here? And it flows back and forth a lot, right? Yeah. And what I love about what you guys do is, okay, we don't care what's on the edge, right? Build an IPsec tunnel to us. But then so now we shift part of the problem, but you still have the other problem as well, which is how do I do authentication into, my SaaS application and partition, and there's lots of people trying to solve this in different ways. And that's why I'm asking, like, how does this change the goalpost, as this rolls out?
So back to your future state question, right? It largely depends on what the outcome the customer wants, right? And what I guess I'm of a mind that there's no real end state that we're ever going to get to. that there's going to be this constant evolution in technology that enables better business, right? Easier access to, we've got this whole AI sort of evolution that's going on. I always think of AI as like a 911 GT3 RS or something like that. It's a very fancy car, except it's, you're driving on a largely legacy riddled pothole highway, right? And so you kind of have to create a new highway system, right? To reach that future state and to solve that problem. I don't, the funny thing about the analysts are, most of them are really wildly smart, right? Especially the analysts in our space. But again, the vendors that they review participate in that market. Right. Okay. So I look at SASE and SSE as sort of an interim step on the way to another evolutionary sort of apex, right? In our space. What you should be able to do is you should just be able to, the browser itself should be secure. And you should have like an RBI on everything. Yeah. And it should come up to a secure environment. And like Hashi, those guys are, I don't know if you've ever, I'm sure that you've explored Hashi and watched all their videos. Like that guy Armand, man, he could teach me how to make chicken soup and I'd probably just be fascinated for hours on end, right? You watch his videos, I'm like, oh yeah, I get it. I know what Vault is. All of this cool stuff. Look,
such a good product.
It's such a great product. We're a Terraform provider as well, by the way. And anybody who wants to create infrastructure through code, it's really cool, right? Yeah. The ability to spin up infrastructure and to spin it down and to do so with 4 lines of code is really neat in my opinion. And look, for us, we believe in the idea of extensibility, and we believe in the idea of you use what you need, and when you don't need it, don't use it and don't pay for it. So our architecture supports sort of unlimited extensibility. And again, it's really just, it's a very big fabric, and you've got a whole bunch of gateways and nodes hanging off of it, no matter what they are. And that, to me, is a pretty good architecture.
Okay, keep me honest.
Yes,
Alkira is dominantly network device, like IPsec to an existing router, an existing firewall. We're not talking about client software that's running on
That's correct.
a computer.
Yeah.
So from an architecture standpoint, when you're making these decisions, is the first decision just really like what your network management or what your control point is, right? Do you want are you managing the network or are you managing devices, right? Because this is a big thing with SASE. Well, forget SASE. Let's just use SSE.
Sure.
Are you installing software on a PC or a Mac or a phone, and then that's creating the tunnel and doing the authentication and getting you somewhere, and you're hoping that the underlay, whatever you're on, is stable. But fundamentally, you're deploying to a computer, right? In Alkira, you're deploying to the network, and you're connecting networks together in dynamic ways.
Right. Well, okay. So there are a bunch of, after the SSE SASE sort of revolution or, interim step, then you get into zero trust, right? We could have a long, arduous discussion about zero trust. Let's not. But, and just like SASE and just like a secure services edge discussion, it's largely the OEMs that are defining the framework for zero trust network, right? And the analysts sort of pick their horse, and we know how that plays out, right? And they pick a couple of horses and they put it in a nice little quadrant. Okay, so it's helpful if you're a customer, and there used to be an expression, and I'm sure you're familiar with it. Nobody got fired ever buying Cisco. Nobody ever got fired buying Cisco. That's the expression. I'm not so sure that's true anymore, but it probably is, right? because Cisco's got fabulous support, and yes, some of their stuff is difficult to deploy and implement, and sometimes it works, and sometimes it works on slides. Okay, but when you at the edge, we do have a client. It's we have a ZTNA client, but we'll work with any ZTNA client, right? Because it's just the machine bringing us a tunnel. So whatever the client software is on the box that the end user is employing, we don't care. It could be ours, and it could be somebody else's. That's cool. We are very much sitting 5 to 10 milliseconds away from every office in America and most global offices around, or most homes in America. And you have your ZTNA client on your box. You bring us that traffic. It lands on the virtual port, and then we distribute it, route it across into where it needs to go on this sort of iterative overlay. Yes, that's our approach. We don't care what's at the edge. And on the LAN side, that's an entirely different domain space as well. We don't go on the LAN side. We go from the other side of the router on the WAN, or other side of the switch or the firewall, whatever is creating the tunnel, and take the traffic from there. It's in a VRF, right? It's in a segment. It's got its own isolated L3 routing table. And then all the way for the whole transaction, you've got this secure finance traffic that's running from point A to point B, no matter where those 2 points geographically are located. And, it's a high throughput, low latency network, like I mentioned. So at the edge, that is not an insignificant part of the network, of course. It's just not something that we do. And it keeps us, I want to say it keeps our hands clean, right? That what we're really providing is network as a service without any hardware, or what it really is network infrastructure that we are renting from the cloud and then re-renting to our customers.
Doesn't that expose you, though, to, we were talking about finger pointing earlier, right? Now you're dependent on client hardware at the edge to actually connect to your service.
Right.
Is their internet connection stable? Do they have the ability to fail over if they're having latency, jitter, packet loss, TCP reset, whatever it is?
Right.
Because not all SD-WAN is the same. And also, if you're using an SD-WAN implemented on top of a firewall, depending on which firewall vendor you've chosen, it's got a very different idea of how it selects a circuit, right? And so how do you manage and maintain that service reliability and that visibility back to a network team when you don't have control over what that connection is?
That's a great question. We do, when the edge device initially builds a tunnel, makes a connection to us, we get access into that last mile from the edge appliance through the rest of the route to wherever it's going. So we've got all sorts of governance visibility tools inside of our solution that will tell you, hey, this last mile isn't stable. We're seeing, latency increase or jitter increase or packet loss increase, all of that stuff. We do get engaged and we white glove everything, right? We're a seven-year-old company. We've been generally available for 5 years. We haven't been down. Our solutions stayed up during both of those earlier, instances I mentioned. But while I can't tell you anything that's happened on the LAN side of the device that's creating the tunnel, I can tell you everything that's going to happen on the WAN side from a visibility, as long as we made that. Look, if last mile is down, we're not going to see any traffic, right? If there are issues with the traffic, your traditional sort of loss latency and jitter issues, we're going to see all that stuff. We've got Wireshark embedded in the tool. We've got other tools as well. We build connections to various SIEMs like Splunk and We've got a connection to ServiceNow for ticketing and all of that stuff as well. But it's all API, right? You can build anything you want. And you could probably have your AI agent do it now through the MCP server. But while we do get visibility, if the last mile provider isn't stable, that's admittedly outside of our domain space and not something we're going to be able to remediate without engaging the ISP.
One of these firewall vendors we've talked about, their appliance for SD-WAN, right, has a 5-minute default for failover built into their config. Like their default config, if you enable it and say, I want to do, SD-WAN and link selection, by default, it's looking for hard outage, and it's going to give you a timer for 5 minutes before it fails over to another circuit, right? It's like,
yep.
Until you experience that the first time, you're like, oh, whoops, maybe that's a problem. But that, right, because it's always this interesting thing for me on like what's on the edge and what's not on the edge.
Yeah.
Right? I guess is the question. I don't know which ones of these I can name publicly here. But,
they're all public references, actually.
Okay, so let's talk about Michael's.
Yeah,
because I think this is
it's a great story, isn't it?
A perfect one. So background.
Yeah, Michael's comes to us. I think it's last year. Could be the year before because they just kind of, the older I get, the faster the years go, right?
I blame COVID. I have no sense of time anymore.
I have a really difficult time tracking when things start. Any which way. So they come to us in September, end of September. They've got a freeze because they're a retailer on November 1.
Really smart. Okay.
Yeah. Most giant retailers have a freeze period, as you're aware. And no IT gets changed. There's no change windows. There's nothing happening. And of course, stuff breaks during that period all the time. And that's probably when you make the majority of your money troubleshooting people's environments between November and January. The beginning of November, the end of January, Max is making dough. Okay. So they come to us and they're like, we have a problem. Our point of sale machine we've got a database up in GCP. We've got the client device out at these 1,400 stores. The architecture was we're running from the client POS to the Michael's data center up to GCP.
Okay.
Right? So they're hairpinning the traffic from the edge through the data center. And they come to us and say, we're having poor performance out of the point of sale machines. A lot of them are not functioning properly. And we're a little nervous that we're going to have a bad holiday season, right? And it's end of September, mind you, right? And so like, okay, let's do a tiny pilot to validate that we can solve your problem. And we'll take a half dozen stores or whatever, and we'll turn them up and we'll show you the process and we'll do a proof of value, proof of concept, and sort of this pilot. And they agree, and we do this, and we show them that if you redesign how you architect the solution, the point of sale machines are actually quite stable. I mean, these are point of sale machines use what? Like at most 3 meg to 5 meg worth of traffic. It's like my Commodore 64 could have run that POS machine. Did you have a Commodore 64?
I did.
Okay. What kind of storage device did you have? Was it a tape cassette?
Cartridges.
Yeah.
Yeah.
Nice. All right. So we demonstrate by re-architecting it. We bring the point of sale machine out of an IPsec tunnel, out of the store, straight up to the exchange, virtual port on our exchange, which is, as I've mentioned a couple of times, 5 to 10 milliseconds away at most. And the point of sale machines, magically, they start working again. We're like, see, so then they're like, well, now here's our real issue. Our real issue is we have 1,400 stores. And now we're into the start of second week of October, I think. Do you think, Alkira, that you can get these 1,400 stores up? Because there's a financial incentive as well, is because a lot of stores still have MPLS, right? So we're back to the MPLS game. We're like, yeah, we think we can do it. So we start rolling it out. And we send a little script. And this takes quite a bit of project management. force on their side as well, because we're working with them and we're on every turn up, right? And we're doing a turn up at 50 stores every day, right? That's what we start with. And like everything goes, we email them the code or whatever. We send them the code. They paste it in the CLI and they bring the store up, right? And we're able to validate that the stores get up, and it's like that. It's really quick. And they're like, okay, now we want to do 200 stores. We're like, okay, let's do 200 stores. And same setup, right? They're well organized. They're motivated. They have this problem and they have a compelling event, right? Which is, in our world, that's a really cool thing, right? When you've got this event that's going to happen, and if you don't bust ass, yeah. So at the end of 10 days, we talk about 14 days, but at the end of 10 days, we had all the stores done. They were all up and running. There was no more MPLS in the environment. And they had largely bypassed the data center that they ultimately ended up, getting rid of. That's, and then Srinivas, he's our champion at Michael's, and he ran the network. We were out at the GCP conference, and and he did a bunch of press for us and stuff, and said, "Look, I'm really excited about what we've been able to do. We've greatly simplified our environment. TCO savings. I know you hate that word, but the TCO savings are significant.
Yeah,
because we did get rid of the data center, and we got rid of the MPLS that was in the environment." And the network is super stable. We can troubleshoot easily. We have all sorts of governance. We can tag traffic. So, we do, in addition to segmentation, we do micro-segmentation through a grouping strategy. So you've got, for instance, in your segments think of them as, it's an isolated L3 routed table, like I said earlier, but they're also like macro segments, right? Where I'm going to put my production traffic in a segment, my non-prod traffic in a segment, my finance traffic, my sales, my POS traffic, my PCI POS traffic into a segment. But then you get down to the micro segment level, and I see this use case evolving a lot as well. Like people will build applications in AWS, but they want to use BigQuery in GCP. And so you're crossing clouds, and there's, how do you do that? Because you've got two different sort of native networking languages and all that stuff. And we use microsegments for that, right? So the front end of the application, because that's all east-west traffic. And that's where you get yourself into trouble, as you're well aware, right? So that front end of the application is accessing that from AWS, is accessing that database inside of, I can talk, it's just my tongue is like not so dexterous, in GCP. So that application can only talk to that database, and anybody from WAN side accessing the application is going to come up to the AWS front end, and then you go get the data set.
How much of this is legacy, and how much of this is just bad design? Not in Michael specifically, but like when you talk about it from like an industry standpoint, like Michael's architecture makes perfect sense here, right? What did they have? They had a legacy application that was in a data center, right? Because they've been around for a long time.
Indeed.
So you have a data center and you have a legacy application. How do you service your POS? You have MPLS because that's what you need, right? You start moving your application in the cloud. How do you connect to it? Well, you still have this MPLS network that's getting, right? This is a legacy, right? You've got all these layers of things that were implemented over the years, and now you have to figure out how to modernize, and it's not easy, right? But the other side of it, which is like, I think the let's say the bigger industry issue, like how much of that is just bad design? Because you could still have, do you need to have a hub and spoke architecture in today's world? Are people still building it? Are firewall vendors forcing people into this idea of like hub and spoke?
That's a great question. So I think, people use the tools that are available to them at the time to seek and get the outcome that they want, which is, hey, I need to go from here to there. It's funny, but I used to work for the guy who built the first DMVPN network and with MPLS for Deutsche Telekom. He was one of the early founders of the Tele. There's all that stuff out there, right? So I think there is there's always a bias for us as human beings to, because we get really comfortable really fast with things we know, and a disruption comes along like software defined wide area networking or multi-cloud networking, and you try to take what is and ultimately evolves into a bad architecture, a bad design, into you drag it into new domain space. For instance, the SD-WAN is a great example, right? SD-WAN in cloud is, but so what happened with SD-WAN, as you're well aware, is like if you're a global company and you have an SD-WAN deployment, there's a lot of latency that you have to contend with. So you end up building 2 or 3 disparate networks, right? And you've got a European network, and those guys might like the Fortinet SD-WAN vendor. And then you've got the guys here, and they like Viptela/Cisco SD-WAN.
Yep. Everybody's on a different division. Has their own roles. Yep.
Exactly. But you largely adopted that strategy based on a technical problem you had, which is, hey, it would be better to have a singular SD-WAN network, a singular policy architecture, a single OEM that everybody could learn and then ultimately on day 2 support, right? But because the earth is a big place and because we have a global, business with offices spread all over the world, we have to build these 3 different sort of islands of SD-WAN networks, right? All right, so cloud comes along, and you want to drag this legacy technology, which is, and I know it sounds crazy to say that SD-WAN is legacy technology, but you want to drag it in the cloud because now you realize, 50%, 60% of my applications have been refactored and now they're in the cloud, and I've got this data center I want to get out of, stuff like that. And so what happens is you end up, putting a virtual, I can tell you a funny story about PwC if you want in a minute, and the reason I left Cisco. You end up putting a virtual instance of your SD-WAN router in the cloud. Okay. And then you have to do what? You need to peer route and configure with, if you're in AWS, the transit gateway, which is a beast, right? It's like putting HA Palos in VPC, right? The manual's 600 pages. Like, I'm not going to read the manual. I mean, maybe I should. But okay, so your question originally started as, is this a bad design? I think it's a function of the tools available at the time, the problems that arose as a result of the tools that you employed, and the new domain spaces sort of entering into the market to enable different business outcomes. That's what I think. So SD-WAN, you put the virtual, you do all the peering and routing, and then something changes. Somebody comes and says, hey, Microsoft's going to give us a smoking deal with their ELA. How many times have you heard that in your life? And we're going to move all this stuff to Microsoft. All right. So you start refactoring all the applications, and you have to migrate all the workloads out of cloud. And then you got to point every device that you have on the ground to Azure. And, Azure's got a fantastic network, right? I'm not sure that anybody works at Azure. They all seem to work at Accenture, but that's a different topic. And I hope that makes you giggle inside like it does me. But okay, so instead of putting the SD-WAN router up there, right? And instead of paying, because it's a Cisco router, or it's a Juniper router that you virtualize, or it's an Arista piece of equipment, or it's an HPE router, right? Whatever it is. You're virtualizing it. You do the routing, peering, configuring that you need. It's talking back to that service router inside of the cloud, the transit gateway, the VNet gateway, the VWAN, the GPC peering point, all of that stuff. Those are complicated sort of transactions inside the cloud. Instead, why don't you decouple the virtual SD-WAN router that's in the cloud and supporting that traffic that's difficult to configure, and just bring it into a stack like Alkira, where you've already got the traffic coming in the virtual port on our exchange point. You've got a VNF of the, let's call it the vManage, whatever Cisco's calling the orchestrator now for Viptela, right there in the middle of the stack. And the transit gateway's largely been obfuscated because it's part of the same Alkira stack, right? So now you've removed the complexity of transit gateway and the virtualized SD-WAN endpoint in the cloud and all that routing, pairing, configuring that needs to go on, and you've moved it into a different domain, but yet you've put it in the middle of all the traffic. So back to the hub and spoke, because I think a lot about this too. When you started in probably, like I used to work at IBM, and I wrote big SQL queries inside of the AS400s. And it was a great job. They paid me, I started at IBM, and it was a long time ago. It was $28,350. And dude, I thought that was like the bee's knees. I had my own apartment, I had a girlfriend, I could go shopping and all of this stuff. Oh man. But I never talked to anybody, of course, which is my problem. Right? So, but that was the environment I started in. And you would just have all the clients hanging off of the AS400. And then I would just work inside of that database and find all the cell phone traffic that I needed to and all the billing, and I'd write these giant queries, and it was really cool, except for the fact that I didn't get to talk to anybody, like I said. And then you had an iteration, right? You had, we've gone from client server, from mainframe to client server back to mainframe, it almost seems like, in my opinion.
Yep.
Right?
Yep.
And so, and along the way, everybody's well-intended, right? They're always trying to solve a business problem that gets them to the outcome that they seek, which is lowering costs, improving extensibility, or doing whatever their objective is. Making business easier for their business users to access the applications that help them do their jobs more efficiently. Let's say that. And yet all of this stuff has evolved just like, and will continue to evolve. I don't know if I don't have a crystal ball, but I don't think there's ever IT is always going to be evolving, and it happens in shorter and shorter cycles now. And so the problem pretty much just stays the same, and the tools we employ and the solutions we employ hopefully change with it.
It's very expensive to deploy large firewalls on the edge. Mm-hmm. There's expensive a lot of different ways, but just like the capacity you need, all of a sudden you start saying, Gigi is inexpensive to put into an office at this point. It used to be really expensive. It's very inexpensive now. 10 Gigi is relatively inexpensive. So the demand on the firewall on the edge is increasing rapidly. When you price out what it costs to deploy these firewalls, even though that cost is coming down, it's shocking. People have these moments. And, you go back 20 years, and you had a lot of service providers and telcos come into the market and be like, hey, you don't have to run firewalls anymore. We can run firewalls for you. And they go out and they buy these big appliances that they can virtualize, and they put it into a POP. And then you end up in these architectures, again, hub and spoke. It's like you never escape it, right? Where, your edge is pinned to a device in your region, and if you're a, company based in Southern California and you're Los Angeles, you're pinned to a device, in SoCal, right? If you were with Level 3 at the time, you were in Tustin, right? It's just where their stuff was. And then you have sold. And then you have an executive who goes on vacation.
Yeah.
And is golfing in Scotland. And then something happens, they need to get onto your network, and they have to pin their traffic from Scotland back to Los Angeles to go back to whatever resource in Scotland.
Right.
And then all of a sudden, it's not so great. Or the other version of this I still see all the time. It's like, you have this cross-border issue between Canada and the United States, where depending on where your IP addresses are presenting, you get different services from your SaaS applications, and like it thinks you're in a different market because guess what? You are. In the case of modernizing these networks, right? MPLS, or let's say you've gotten off of MPLS and you've got some sort of, manufacturer firewall edge going into a data center, and now you're moving your applications into the cloud. How much of this is just the change management issue of being like, because you could a firewall manufacturer going to come in and say, hey, you can build a VPN endpoint from your device on the edge into your new Google Cloud, AWS, Azure, Oracle, whatever it is that you're using,
right?
Just as easily, right? Like they're not going to say you can't build VPN endpoints to it. It's auto magic configuration, right? They offer SD-WAN, right? So that's why I circle back to like, how much of this is legacy and how much of this is just bad design? Because when you start talking with these firewall manufacturers and force them to actually whiteboard out their architecture and their design, 2 and 2 does not equal 4. Like it gets really interesting very fast if you dig into it.
So this is a super great question, because I don't, again, like you and I start in whatever, early 90s, right? And we are trapped in sort of a mainframe world, dumb clients hanging off mainframe. And then you had things like Citrix, right? Where you're doing VDI and all sorts of cool stuff. I thought that was really cool technology.
I still think it's cool. It's shocking that it's not ever been adopted in a mass scale.
There are a bunch of cloud players that are talking this topic as well.
I know them all, but
exactly.
But in terms of like actual end user adoption, it's always shocked me that it hasn't been adopted that much.
Again, I'll go back to the idea of, I think we get trapped in this idea of, I use this example a lot. Imagine being the first fuel injection sales guy, and you walk into Ford or GM or Chrysler and you say, hey, I've got this killer new technology, and it's going to regulate the amount of gas, air, and electricity or spark that gets into the cylinder. And it will do so at multiple altitudes, and there's no day 2 maintenance. Ford tells you, GM tells you, and Chrysler tells you, hey, the carburetors work for 100 years. We've got a whole line. In fact, every manufacturer in the world has a whole line set up to just build carburetors. The first fuel injection sales guy is the most frustrated person on the planet, I suspect. Because he or she can argue, look, this is a better solution to the problem you're trying to solve. It solves more use cases, and it's cost equivalent. There's still a bias to rely on designs that are tried and true. And I don't know how you eradicate that bias. And so, yes, there is just an absolute ton of crap-ass designs out there, right? From the 3 separate SD-WAN global networks that you're maintaining and the different firewall. I've heard certain people argue recently that firewalls, especially next generation firewalls, are no longer relevant.
I don't even know what that means, that term, by the way.
Again, that was an analyst term.
Yeah.
Actually, I think Palo came up with that term, right? That term. I think we're trapped in our own bias as professionals, because if the carburetor works, we stick with it until we're forced to move. Now, you drove here in a car today, and I was driven here in a car today, and there's no more carburetors on the road, man. How did that happen?
I love your analogy.
Thank you.
I'm also going to argue with you about it.
Please do.
If you watch any videos, okay, so now every car for fuel efficiency standpoint, so fuel injection, way more efficient, your example, right? It works at altitude. If you've ever been in a carbureted car and you change altitude, right? Like, it's a problem.
Yeah.
This is a serious issue. Fuel injection solves that problem. It's way more fuel efficient.
Mm-hmm.
Next iteration is cars have to stop and start.
Right.
So cars that stop and start create more fuel efficiency. They're using less gas.
Mm-hmm.
Byproduct of that is it requires a lot more complexity in the system now, because the car's constantly starting and stopping. You have issues with your temperature regulation for your cooling system.
Right.
Videos of mechanics taking apart engines to fix thermostatic couplers and these systems, right? So you go back to your carburetor. The carburetor had a valve, right, that was like this thick and like this big around, and a hose that was opening and closing based on temperature.
Right.
Now, if you had we were on a road trip and our thermostat failed, right? But it turned out that you could just like the tow truck guy was able to just like unplug it, remove it, go in. We were able to get to a shop. Nowadays, this part is like, this long and 6 inches around and has 47 hose fittings on it and a computer control chip and like everything else, right? It's so so that analogy, I love the analogy, but at the same time, that analogy is introducing a lot more complexity.
Indeed,
into this environment.
It's so I have a good story. So Koch Industries was one of our early customers. Koch Industries has about 75,000 employees. They've got 100 plus business units. They own Infor and TNS and Windix. All of their sub brands roll up to Koch. Fair disclosure: Koch Disruptive Technologies was one of our investors in one of our early rounds, and Koch helped us with feature and functionality early in the cycle. And Matt Hogue is their CTO, is a friend of ours from the Biptela days, where he, also helped us develop, because he's the customer. He is the ultimate operator and end user, and he had some really good guidance for us early in our tenure here at Alkira. He had a really robust deployment in AWS, and he'd spent, I think, 6 to 9 months developing automation to take his 100 some odd business units and his 75,000 employees from the 70 different countries and get them attached to various AWS tools. The thing about the automation that he built is, I think of it as kind of static. I know that's counterintuitive, but it's ultimately, you never want to automate complexity, in my opinion. And you're absolutely right about the fuel injection, right? I remember one time I had to replace a headlight on one of my vehicles, and the mechanic says, so I look it up on YouTube because I'm going to do it myself, right? And I have to take the front bumper off of the car and then disassemble like a whole bunch of other stuff to get to this. It was one of the modular headlights that it was a German car. I'm like, this is stupid. Like, just in terms of the cost benefit analysis of me taking the 3 or 4 hours that it's going to take to do this, and then, going out and getting that extra tool like the impact wrench or whatever that I'm going to need that's not going to work. So I'm going to pay somebody to do it. So yes, what we've really sought to do is to remove the complexity, right? So we are largely a routing engine. There are a whole bunch of compute and service nodes inside of our stack. It's sitting in the cloud. But your point is taken, right? In Matt Hogue's example, the CTO, what he discovered after this deployment, and it was almost by accident, when his boss comes to him and says, hey, great job on the AWS stuff. Can you now go do it in Azure? Because we just bought a company and they're entirely in Azure. And Matt's like, no, I'm not going to do it in Azure. That's insane. And it was trouble to just do it in AWS. And I've automated a lot of complexity, right? So one of our design principles was to not automate complexity. But, a network is a complex and living thing. And there is a certain amount of complexity because you're making thousands of connections and things are traveling at, 1,000,000 miles an hour all the time.
What's an ideal customer for you? Because a single location, I've got Microsoft 365 or Google Workspace and Salesforce and like a, traditional kind of like knowledge base. Like that's not going to be a good Alkira customer, right? So you could solve problems for them, but they're not going to come seek you out, right? They're not going to associate that pain in terms of like, go fix it.
Right.
What is that? What is the line that crosses and really separates like this is where we solve problems?
Another great question. Thank you. So I think if we go back, so I've been here 4 years. I think the problem that we solve, remediating complexity and normalizing communications between the various cloud service providers and providing network infrastructure that they can use when they need it and not use when they don't want to pay for it or don't need it, is we were early to market, right? there were, again, 4 providers in the space. It always seems to happen in 4s in the valley, right? There, one was purchased, one closed up shop, and you've got sort of 2 remaining. And the third that was purchased with no customers for way too many millions of dollars, and it's been integrated into a big OEM, and they don't do a whole lot. There's your context for you. The cutoff of the line where it makes sense is the market's now more mature. And the problem, like, we've been working in white gloving everything along the way, and our customers have traditionally been very large enterprises. That doesn't make our solution any less relevant for the person with 10 offices and a cloud workloads and 2 AZs inside of AWS across 2 different regions. It doesn't. It makes us, we're still useful for that.
It's an incredibly complex environment. I mean,
that's right. Yeah. But now the problem is more pressing. The large enterprises obviously wanted to be multi-cloud because of the earlier example I gave about GCP's losing of the $54 billion pension fund, right, which is not ideal. So everybody distributes workloads, and they use different things in different, you SharePoint, O365 inside of Azure, and you might use Copilot, and you want to distribute Copilot to all the ends of the earth, and you can't get it in China and stuff like that. We can, right? Which was pretty cool for one of our customers. That was one of their use cases. I thought that was really neat. So the market's now more robust. More customers of different sizes are multi-cloud. But we used to think of it as if you had 10 separate cloud workloads, right? Or something like that. And let's say a half dozen offices, and you had an AWS guy, but no Azure lady, or you had a GCP person, but no Azure or AWS person. That was, kind of the benchmark of the threshold for when it made sense. From a cost perspective, and because when you adopt Alkira, right, you are re-architecting. Just by definition, you're bringing us the traffic directly. You're avoiding a landing zone. You're avoiding configuring any of the cloud service barrier routers, right? Like the transit gateway, VNet gateway, all that stuff. And you're able to, I'm going to use your least favorite word here, consolidate services by virtualizing them and putting them in as an NFV or a VNF, whatever you want. So that the savings should be significant. The larger environments have more savings. The smaller environments, there's sort of a cost equivalency that you're working towards. But and then day 2 operational savings is significant, right? You are operating a complex environment in a simple way with less people. So that saves you dough. So I guess it's a hard question to answer because it's sort of a moving target. As the market matures and the problem starts to rear its head in more enterprises and SMB spaces, people will go and search out multi-cloud networking, network as a service, cloud networking, cloud internetworking, all of those things, or even a cloud VPN or something like that. I'll get you to us, right? Right now, I think you can have a single cloud, but multi-region. And even with 2 or 3 VPC, VNets, VCNs, or Google VPCs, that makes sense. Because that, even though it's a fairly modest environment, is still quite complex, as you know.
My brain's spinning, like listening to this, because
my brain always spins.
One of the things that's really interesting to watch is vendors that come out to solve a problem that technology inevitably solves. And what I mean by that is, like, there's SD-WAN vendors that came onto market, and the problem that they were solving was for high latency, low bandwidth links. And if you were operating a gas station chain on the interstate in the middle of nowhere and you couldn't get fast internet, that was a big problem for you because you had a point of sale terminal that you had to support, right? Time passes. and now we have Starlink, and you can get phenomenally fast bandwidth everywhere, right? So no, you no longer need an SD-WAN solution that solves for low latency links. So what is that? In that, so it's that like frame is interesting of like, are you solving a problem that something else is going to solve for you inevitably, right? I've seen, it's like if it's cost, like instead of, yeah. But here we're talking about solving a problem that is this driving complexity that will never leave. We're going to buy a company. We're going to sell a company. We're going to move into a new market. We're going to leave a market. We're going to go from one cloud to another. We're going to change a productivity app, right? All this stuff happens. And there's a lot of complexity that always gets injected with that, right? Change, right? So now we're talking about how do you support people through change, right? As the driving factor here. From an architecture, I get back into this idea around, what is on if you have an edge and you have an and you have users on the edge, now you have SD-WAN on the edge to manage your bandwidth, right?
Right.
An SSE vendor will say, hey, give us the IPsec tunnel, take it to us, and then we're going to manage all of your connections with us. Then we're going to do, that function, that routing. And you're saying the same thing, which is, hey, give us an IPsec tunnel, take it to us, and then we're going to provide this routing for you.
Right.
How does somebody like manage that friction between these two decision points?
So let's peel the onion a little bit. And I think it gets down to what outcome you're seeking, where you're distributed, how many workloads you have distributed across different cloud properties, different data centers, to include Equinix, Megaport, QTS, DRT, well, DRT here, as we sit in Dallas. If I'm using a Zscaler and I've got a ZIA, I keep storage in AWS, one of the buckets in AWS. Fairly common deployment. What I do as a user, if I don't necessarily have a data center, is I might go up to cloud to access an application resource. But because I've got Zscaler, this is, I'm sitting in a hospital the other day with my mom, and I'm trying to get on the hospital's Wi-Fi, and I was looking at vehicles on autotrader.com, believe it or not, and I couldn't get through the tunnel. That was not, I'm like, what the hell is going on here? The architecture is funny, right? So I leave the cloud to go to the Zscaler proxy, get the traffic inspected, return to the cloud. Now, mind you, I paid egress as soon as I left the cloud. And it's either 9 cents a gig an hour over internet or about 4 cents over a layer 2 circuit, like a direct connect interconnect from Google or Express from Azure. Those are fairly common egress, and they're all gigs per hour, right? So I come back in the cloud only then to leave the cloud again and go back to the user. Okay, so with all that in mind and that crap ass architecture, back to your question. Yes, bring us an IPsec tunnel, bring us one of the aforementioned cloud layer 2 circuits, give us an MPLS circuit, we'll peer with the provider and their VPC, VNet, VCN or whatever, and then bring the traffic back to our stack. Or SD-WAN fabric, land the SD-WAN fabric on our virtual port. You have some, you go and get the resource, the application resource, the storage, the database, whatever you're looking for inside of the cloud, and there's no double egress, right? And so not everybody does that. Zscaler is a special sort of example, right? And I don't want to knock them. They're a great product. I just don't want to pay double egress for ZIA at least. ZPA is a different thing, right? Because they keep most of the private stuff in the cloud. It's just prohibitively expensive, as you're well aware. And we have a lot of customers that are leaving Palo Prisma because of cost and limited route functionality, and all the stuff about that as well. And so it's a tough question, because the ask is what you see in the OEM space is you see, like, if you look at Megaport, for instance, and I have friends, lots of friends over at Megaport who probably won't be my friends after this podcast. So that's okay. I can live with that. Megaport sells, like 4 years ago, we were talking to Megaport about, potentially partnering. And then all of a sudden their messaging shifted a lot, and it looked a lot like our messaging and the stuff that I was talking to them about and how I was talking to them about. And it was being my architect, David Klebanoff, was a genius and the real reason behind Alkira's partner success. Anyways, Megaport does exactly the same thing that we were talking about with the virtualized SD-WAN router in the cloud, right? Megaport is an on-premise data center company that provides connectivity globally, and they're really good at it. But a lot of applications, if not the majority of enterprise applications now, are hosted in cloud service providers, or they're some SaaS app in some data center that has been virtualized already.
Megaport was started to solve two problems.
Mm-hmm.
They were started to solve connectivity between different data centers, especially different data center vendors.
Yep.
And they existed. You have to remember, when Megaport started, you couldn't talk natively between AWS West and East.
Right.
There was no infrastructure between Amazon to facilitate that for you. So you needed a Megaport in order to actually connect regions. And so, it's really easy to bash on companies for being single region on Amazon, but if they're old enough, they started in a time where you couldn't be multi-region in Amazon because there was no support for it.
Right.
And so Megaport solved those two problems really well. And then other companies started that solved the Megaport, what Megaports was, Megaport has a lot of facilities globally now. They've got a different legacy issue now. What's the speed of their links? How do you scale these things? And then, but then of course the ground shifted underneath of them. Eventually the clouds, AWS came in and said, hey, you can natively talk between regions now with us. You have to just click a few buttons, right? That changes what problem they're solving for a lot of people. And that's, it's like this thing. It's like, are you a feature or your product? And if you're in the business of solving a feature need on somebody else's product, like, your days are limited. They will eventually catch up with you. Like, absolutely. At some point, it'll get there.
I think, though, the Megaport, and I'm not arguing with you at all, they made a really smart strategy early, and it was probably it was not a strategy of convenience. It was a strategy of need, where they partnered up with Equinix and a bunch of other colocation providers to expand their reach, which I think is genius, right? It increased the cost of goods sold to Megaport, and the margins that they paid partners to build those relationships were costly, right? But then you have, the evolution of cloud and multi-region cloud, right? That is impacted. So the ground, you're exactly right. The ground sort of shifted under their feet. But remember, cloud is an abstraction. It's a cross-connect from every colo provider and data center. Colo provider and data center provider in the world.
Yes, except when you start getting into the technical requirements from some of these cloud vendors to get an interconnection with them,
right.
Like, oh, you have to be at two different facilities inside of a metro in order to hit this service tier, and then it requires this and that and the next thing. And you talk about like network engineering being a dying art. Like the amount of people that can actually configure PGP has got to be like, we're not talking about a big population that understands this stuff.
No.
Like, whiteboard, OSPF configuration as like a, as a thing, right? Like,
I don't see it anymore.
Right. It's a.
Do you?
Well, I get paid to solve these problems, right? Like ultimately, we solve application performance problems for a lot of enterprises, and I guess this is where like it's worth it to be the old guy with no hair now, right? Because we've been through this. I've seen a lot of this stuff. But it is weird. It is weird how that's changed. And the part that I always come back to, and I think about a lot in our conversation here, is just talking about, it's like, how much of this is solving legacy? How much of this is solving bad design? Maybe the third part of that is how much of that is solving capacity, and just the do you have the resources internally to actually manage this stuff? And the answer is no. Like, I don't know a single organization that can effectively like
Right.
Like you can't. I mean, this isn't a knock on anybody. Like no IT team is staffed at the level that they need to be in order to even think about like maintaining one cloud vendor, let alone being like, okay, we want you to now maintain a second cloud vendor, and on top of that, we want you to maintain the network. Oh, and now you have to also maintain the applications.
And we just acquired 3 new companies, and they have 3,000 locations, and they're distributed globally, and they use a different cloud than we use.
Oh, and by the way, we're also selling off this division, so you have to separate that off our work as well.
It's a divestiture. Get started. I had a funny story for you. I was at Cisco at the time, and was down at the Lennar offices, which is a home builder in South Florida, and they had just purchased an entity. And I think you appreciate this. I hope you will. And the entity, actually, the other home builder that they bought was like some local South Florida place, right? And they had, and I'm not kidding, I said, well, when did the purchase? I'm sitting in office. I'm like, what's that over there? And like, well, we did this, we purchased this company. And I'm like, well, why is that Cat5 cable hanging out the window? Because we're running it across the parking lot. And I'm not kidding, dude. It went through an oak tree, or what I thought it may not have been an oak tree. And it was hanging over there. And then it went to the other office. It was a long cable. And I'm thinking, this is an odd way to combine corporate networks. But it was the way that was fast and expedient, not very costly. But so in your example, there's a subset of human beings on the planet now that can manage BGP effectively, right?
I love this story because I've been that guy.
Right.
And what's funny about that story, and the reason why I'm laughing, is knowing the conversations and the meetings that occurred before that cable was just thrown through a tree. Because that wasn't the first path, right? There's probably like 200 hours worth of meetings that fed into that. And, and of course I have this other saying, which is there's no such thing as a temporary patch cord, right? And so now you've got this probably non-UV shielded cord running through a tree that's just slowly baking in the Florida sun and degrading, right?
And it's humid as heck there, so all the best.
Yeah,
electronics.
I've been that guy. I've got lots of stories along those lines.
So we were, M&A happens to be kind of a specialty of ours. Because we were early to market with sort of a very disruptive technology that people looked at and said, oh, well, we don't have that much cloud yet. And, come back to us. We found ourselves gravitating to use cases that we could solve faster than anybody else in a less complex way. And one of those was M&A and divestiture. So I'll give you I guess we can talk about Kellogg's, not a customer yet. And then I'll give you S&P, right? S&P wants to do a merger with IHS. It was part of an acquisition. And they're like a lot of different entities, very diverse entities, very globally distributed, of course. I had no idea that S&P was so global in nature, right? And they had anticipated it would take 2 years to do this M&A, right? To bring the other entities into the corporate environment, corporate network of S&P. When they got engaged with us, it was Guru, who's the VP of infrastructure and cloud there now. He wasn't that when he started, but he's done a good job, and we helped him. And he's kind of risen up inside of the stack, inside of S&P. So, S&P is a global research company, right? And they provide market data all over the world. And they have customers like traders and researchers and analysts that consume their research and do so from different entities, from banks, from financial advisors, from, this, that, and the other. But this IHS merger created some problems. Like, you're talking about how many different types of routers, switches, firewalls, how many different types, different clouds, how many different office locations, how many different SD-WAN vendors in there, how many different policies that the various firewalls had. That all of this stuff needs to be taken into consideration, as you're making this giant integration or this giant change. So they thought it was going to take them 2 years to get done. It it took, like 6 or 8 weeks after we got involved, because they use us, and it's the same reason that our big banking customers like us as well. It's the ability to extend a VRF from their VPC to the customer VPC, VNet or VCN or data center or whatever, and to do so securely in that segment. And it's immediate, right? It's like, okay, let's start this process of bringing in this other entity, combining the IHS and S&P Global. When they look at a 2-year timeline, that's all they're doing for 2 years, right? If they can do it now, then they can move on to the next project, which may be some sort of AI thing or something.
That was something about that example is a light bulb for me. I think it just really clicked off. And think about like routing architectures. We're talking about like BGP and OSPF, and I mean ERGRP. Pick your flavor, right?
Such a Cisco guy.
Listen,
fair enough. Me too.
Just as a segue, being able to call some rando shop in the middle of the night in some market and say, "Can I get a part that I need?" When you look at hardware selection, like, nobody's going to tell you that Cisco is the bleeding edge of anything or the fastest. And there's a lot of other stuff that Arista's amazing, Juniper's amazing. Like, these boxes are unbelievable.
Yes.
But when you have sent a network engineer to drive down the freeway to meet somebody who has a part at the halfway point and then drive back to you, like, I think about this stuff, right? Like, it's a part of my selection criteria now of like, right, we've got this box that now we have to maintain for the next 7 years. Like, how do you get parts for it, right? So now don't get me wrong, running 6500s and 7600s through, the BGP table, climbing rapidly and having to maintain those things was very stressful, and finally getting into ASRs and like seeing these other things, and ASR finally introducing functionality that Juniper had for years, like, but anyways, that's a big segue.
I mean, the feature.
Oh my goodness. Right. As a sub, yeah. I mean,
it makes a little bit of sense, doesn't it? It's like copy and paste on an iPhone. Like, come on, man.
Listen, I can remember. Very late 90s MPLS network. When I say MPLS network, I mean really what we're talking about back then was like frame relay,
right,
hub and spoke, right, rolling out new infrastructure, and doing a live routing table replace on the edge with Cisco, and basically applying the config very strategically, because as soon as you pasted, you hit that line and then you lose the connection, and then you have to sit there and stare at the screen while your ping is running and just exactly praying for the config to come back online. And if it didn't, your fallback was calling the person on site and telling them to go unplug and plug the device back in and praying that the previous config was loaded properly. Don't want to do that ever again. But I'm going back to this thing with the light bulb here is, even today, I don't want to deal with complexity myself. And from a architecture and routing standpoint, knowing what it takes to deploy routing across just a single network that's got different locations, and what the peering of those routing tables has to look like, right? You talk about BGP. This is a very specific issue where with each device that you add onto the network, the amount of connections that you have in your router grows exponentially. Like, it's,
yeah,
and like BGP solves it by having route reflectors, right? But you look at this and you say, okay, I would be willing to pay to not deal with that complexity on my network, especially because it requires less hardware for me to manage. Like, the issue with routers becomes you have to have enough horsepower to process the routing table. Like, what's in the rib, what's in the fib, how big is your, what's your TCAM? Like, all these things become real big selection problems for you in sizing your hardware. And then you say, okay, great. Now you have to double your adjacencies overnight, which is really not like a doubling of your adjacencies. Like, it's a big issue. Do you even have the hardware capacity in dealing with that, right? And then how do you deal with segmentation? Like, and so I'm trying to regurgitate a little bit of what you've told me here. That's like it's really clicked off of not having to deal with that as a network engineer. I'm all into like 100% on board with, right? Especially if, and my part of it always became, can you simplify and can you lower, can you get into commodity? Can you buy simple devices? Could you still run these really inexpensive ISRs on the edge? Can you have a really inexpensive firewall that's doing SD-WAN for you on the edge?
Right.
My favorite redundancy is N plus spare, right? Like single device running with something in a box that's not even plugged into the network, right? Because it's really simplistic. You don't have to deal with it, right? Like, oh, it failed, it went down, we have to replace it. Somebody has to go and plug the, take the box out and plug the new thing in. And I know people think I'm crazy when I say that, but adding HA into a lot of these environments on the edge, like that's a significantly more complex environment that you have to maintain and configure. And then you find out that you didn't configure it properly and it went down,
Good story. Shoemaker with the whole 400 resale stores in LATAM. Let their Fortinet firewalls that were creating the tunnel for the POS machines to get back to data center in America. Let them go end of life. The boxes were so they're unsupported and they've got no way to effectively get new boxes in without paying a fairly substantive tax bill, as you know, right? Importing gear in
Yep.
to most countries is significantly more expensive than not. So what we offered them was, look, point the existing Fortinets to, I think we were going to Mexico City at the time, right? So we drop those into the Mexico City AWS POP that's down there. It's got a transit gateway, right? We have a CXP instance there, and we get, we remediate the near term, this box could die at any minute need. And we take the top 50 stores where the boxes are the oldest, plumb those into the virtual port, and then swapping out the boxes becomes a lot easier because effectively you've gone from having a point of sale machine dependent on a Fortinet router that's end of life, end of support, and you can't get new parts for, and you can't afford to, because it's a discount shoemaker, right? Or discount shoe seller. You can't get the box in there. So what we did is we did 50 stores at a time, right? We identified the oldest boxes first and then removed that they had picked, I can't remember what they picked, but they picked a different hardware manufacturer and they brought the boxes in. And we were able to sort of, it wasn't so much a wholesale rip and replace. What it did was it helped remediate their risk, 50 stores at a time, right? And they were able to source the boxes where they didn't pay as much taxes from a distributor inside of Mexico, which is really the way to do it. And they probably paid a little bit over premium for it. But they were able to do the stores and get everything up without, they took a risk, right? Because they were doing 50 stores, but because we're so easy to turn up and so quick to bring stuff online, we were able to tell you, we were able to get that environment turned over pretty fast.
There's still a perception that dedicated circuits are faster than using something over the internet. Right. So this is like part of the thing with MPLS. Now we see it with cloud connections. Oh, we need to get a physical circuit to connect us to our cloud, right? Pick, Direct Connect, Express Route, whatever it is, right? I don't care. I don't prefer that architecture, right? Because now you're going to some sort of, telco provider and saying, I want X speed circuit at this location. You're waiting for their provisioning time, weeks, months.
Yep.
You are capacity limited based on whatever they give you. You've got a failure point that you have to deal with. And you're still writing the same underlying infrastructure to the cloud. It's just like, what are you actually writing on top of where you, but because there's less pieces in that puzzle, usually for most companies, the circuit is faster, right? Because it's just a layer 2 connection that's running up and they don't have all this other gobbledygook, that's there. How do you help people with that? Like change that mentality and say, look, you've got a device over here that IPsec into us. You don't have to get into this crazy stuff. You don't have to go out and provision this thing. You've already got enough bandwidth to it. Just try it, just plug this in and turn it. When I say plug us in, type on the keyboard and configure us and turn this on.
There's perception out there that the private circuits are more stable than internet. I don't think that's far away from the truth, but I also think that, Riverbed would still be in business, or at least productive, if the internet wasn't so robust and so stable. WAN optimization would be still a technology that we employ. And sometimes I still run into WAN op boxes, as I'm sure you do, right? For critical workloads between long distance sites or what have you. So again, we're the middle mile, right? But we're dependent on the last mile. What I typically see is they'll put, and we can do 10 gig IPsec now, right? And then you're sort of unlimited in the cloud, right? Our boxes, I call them boxes, but our stack, our virtual colos in the cloud can go anywhere from 100 meg of networking to 20 gigs. And we're deploying 2, and they're HA. We maintain both on behalf of the customer, but the customer pays one. And we pay for the other ones so that we can upgrade in production. We'll swing the production workloads over the backup, do the bug fixes and feature stuff that we need to do. And we do this every 30 days. Then we swing the production workloads and do the reverse and do the same on the backup, the HA pair. So what we see mostly is people adopt a direct connect or some sort of private circuit out of their data center because they think that's still a critical, technology that's never going to fail. But my bias is if cloud is the new data center, internet's the new, MPLS or new transport option, right? And it's stable. And there are 100 gig stuff out there. There are 400 gig requirements out there. People are doing some crazy stuff.
Doing 8 right now.
Dude, I know. It's so crazy. I'm like, are you moving the Library of Congress every millisecond?
It's amazing.
The stock exchanges, we have a couple of stock exchanges, right? These are Singapore Stock Exchange and Hong Kong Stock Exchange. They're just, and then although they're not a customer, the London Stock Exchange, that was the first 100 gig requirement I had heard of a couple of years ago. I'm like, really? What are you going to use it for? I mean, that's a lot of throughput. Come on. You're jamming every piece of data on the planet through that pipe per second.
Not slowing down.
No, I know.
I
see AI evolving.
We're a couple of years away from terabit networking as a common construct. It's amazing.
Right.
It's,
anyways, we help people from just orchestrating an easier architecture, and whatever they bring us, we terminate. Right. It doesn't matter. It could be an Akamai Prolexic fabric. It could be any of those L2 circuits we're talking about that cloud service providers have. IPsec, SD-WAN, MPLS. I talked about how we pair with that. Our solution is we're going to give you some guidance, but we're also going to accommodate everything you have. And I talked about Matt Hogue earlier. He was really instrumental into a lot of the stuff that we're doing because we were helping him replace that automated AWS and get him sort of like for like in both Azure and AWS so you could accommodate the new thing. But we always accommodate, or we try to accommodate what our customers want to use, because I could talk all day long about CloudGenix's architecture and it's inline and what happened to us at that big bank and that dual inline memory module and catching fire. And that's not a popular thing to do in the data center all day long, but customers are still going to have a bias for solutions that they've used in the past and have secured their environments. And, and I think it lengthens the sales cycle to fight with them about that. What we do is provide them with an easy to use, better, extensible architecture. What they have in their environment are things that they have deep attachments to, and this firsthand. Why are you still on the ASR platform when Cisco's charging you 10 grand for every extra port you consume or something like that, right? The Juniper box is pretty good. Arista has a great solution, right? So
all layer 8 issues.
Right. Exactly. People have They just sort of have this agreement with themselves, makes them comfortable in there, and they know they're going to get support. Cisco's never going to let them down, right? And having been on, funny story, big accounting firm. There was a balance of trade between Cisco and this firm. I walk into this. I didn't sell the deal, but it was $11 million worth of Intel stuff that we sold. The rep leaves. I move into the enterprise slot, and I'm a Cisco PSS. And it's me and Katie Sikora, who is hands down the best network engineer in the world for my money. Hands down. She's at Alkira with us now, too. She and I are on the phone every day, Monday through Thursday, with this shop, because we can't build an IPsec tunnel between two different regions out of the virtual ISR router and the vEdge, for that matter, between the two AZs inside of AWS. And we're like, okay, this is never going to end, right? We figured it out after 90 days, but it really became Katie looks at me one day and she says, I wish we could do what we say we do, with respect to all of this stuff. And so that's kind of shaped how we go to market. It's like, look, we do what we do and we do what we say we do, and it works, and we haven't been down, and our customers are sticky, and we haven't lost any. And so I don't know. You're never going to solve for people's biases. It's just,
nope. Just try to make their lives easier in the process.
Yeah, exactly.
That's it for this episode of Signed. If you got something out of this, share it with someone in your world who's staring down a tech decision. A CIO, a CFO, a founder, a procurement lead, whoever. That's how the show grows. Everything from today lives at itbroker.com/podcast. Show notes, transcript, links to anything we mentioned. If you're in the middle of a real tech decision right now and you want someone in your corner without the vendor bias, that's what we do at itbroker.com. Schedule a call on our website. Buy tech without regret. I'm Max Clark. Thanks for listening. See you on the next one.